Okay, hello everyone. So this problem, I'm choosing to do it because it's very, in some sense, silly because it's so easy. But that is why I'm doing it, because I want to stress to you that I do not care about this problem. I don't care about the answer to any problem. When I'm looking at your work, there's one thing I care about. I only care about one thing. Okay, so even if the proof seems really easy or silly, like in this case you'll see it's sort of silly, I still care that you carefully explain the logic. That is what I'm trying to determine, whether you are able to carefully explain the logic of this proof, even though it may seem like a silly proof. And so this applies to every single proof that you're doing in this class. I only care about one thing. Okay, so let's take a look at what this means in this example. So first of all, if and only if means that there's really two proofs. Sometimes the symbol is this, and you can write that as /IFF in LaTeX. And what this means is that there are two proofs. You need to prove this way, and you need to prove this way. In other words, the first proof, and I'm carefully explaining, so I'm going to say exactly what I'm assuming. Assume that a sequence of z sub n's converges to 0. So I assume this, and then I need to show that this is true. Okay? So assume z, and then I'm going to explain to my reader, carefully explaining what I'm going to need to do. Need to prove that the zn goes to 0. And what does that mean? I'm going to carefully explain. That means that we need to show, how do we show this? How do we prove this statement? Well, we need to show that for all d, there exists a capital N such that past that capital N implies a certain distance is less than d. What distance? Well, I look over here and I write exactly this thing minus this thing. Okay? And then I come back over here and I realize I didn't say what is d. Is d an elephant? Is it a integer? What is n? Is n a giraffe, or is it a natural number? D must be a positive integer. N must be, actually this could be a real number. I like to think of it as a natural number, but if you did find a real number, then still, like all these are natural numbers. So they can still be greater than or equal to a real number because the natural numbers are contained in the real numbers. But either way, you should say what it is. I'm going to say that capital N is a natural number because I'm thinking of it as the z sub capital M, the last one, or I guess the first one, where everything is inside the ball. Okay. So I'm carefully explaining that means we need to show that for all d, there, I just realized that is not the right symbol. It should be this symbol, or /exists in LaTeX. So I'm carefully checking there exists an n. All right. So how do we do that? Well, we start the same way every time. Choose d, a positive real number. Okay, now I need to use my assumption. Because of this, and why don't I even, well, I'll say, because zn converges to 0, we know there exists some, and I'm tempted to say capital N, but I already sort of have that in mind, so I'll say capital M. there exists some m such that all the little n's greater than m imply something is less than d. Now, what is that something? Well, over here, I take this thing and minus this thing. Very careful. Okay, now the claim is that we can choose n equals m. Now let's see that. So now I'm going to calculate. So here's my claim. We can choose capital N up here equal to this one that we knew existed because of the thing we assumed. So let's see why. Well, I need to show that this is less than d. So let's start with that. Cn minus 0. Okay, I would like to eventually conclude less than d. Okay? And so that is what I will do. What I know is that this is less than d. So if I could transform this into this by calculating, I'm good. Okay, well, subtracting 0 is just going to leave exactly z sub n. Now the size of z sub n is just the size of z sub n. And then I can subtract 0 without changing the thing inside there. When you subtract 0 from something, you don't do anything to it. And now I'm done, because I know this thing is less than d. As needed. Okay. This was a very careful proof of one of the directions. Okay. I am now done with this direction. I still have to prove this direction where I assume this thing and then show that this thing must be true. And again, do you see what I mean, how silly this is? Like, this is quite a silly sequence of equals signs. However, I don't care. I really, really care about one thing. To carefully explain the logic of the proof. Okay? So, did I do that here? Yes, I carefully stated what I'm assuming, and then I told the reader exactly what I'm going to try to prove, just to let the reader know what is going on. And then I decode that. I say, hey, by the way, in case you forgot, what does that mean? Well, that means I need to prove this. Okay, and now I set the stage. So up here I was sort of setting the stage for the reader. That's my carefully explaining. And now I'm ready for the logic. I begin by choosing some d. Now I have to show that I can produce an n that will work to give this, okay? And then I do that. I choose the d, and then I know that since this converges, there exists some m that this holds, but then I show that this thing is equal to that thing, and so therefore it's also less than d. And I do that very carefully, okay? So anyway, I hope this makes the point. Now, you wouldn't be done. You would then have to repeat this for the other direction, where we would assume this and prove this. Okay? Now, I think it should be basically the same calculations that lead to the result, but you'll see that the words are all completely different. All right, you need to switch around the words and put them together very carefully to show that you understand the logic. Okay. So this would be not done yet. You'd need to show this part. Okay, I'll leave that to you.